Hey guys, we'll be going through the question 4 in today's Leetcode contest, so let's get started. Yeah, so problem 4 was minimum cost to buy apples. So I'll explain the problem statement. Um, so, like, basically, we got a graph, right? There's some graph, and in the graph, what we have to do is like each node has a certain price associated with it, and each edge has a certain cost and a tax associated with it. Okay. So yeah, now what we have to do is like this is the price of the apple. Okay. So for each node I, you have to start from each node I, and you have to go till any node j. Okay. So, and then you have to buy the apple at j for price of j, and then with those apples you have to go back to I. Okay. So now, since you're traveling without apples from I to j, it would simply be the sum of the cost of the edges that you choose, of edges that you choose, that we choose to reach j, right? And since you're traveling with apples, so this road is without apple, and this road is with apple. So with apple, it's simply sum of cost of edges that we choose into the tax of the edges that we choose to travel, right? So your total cost, seeing this diagram, your total cost is d of ij without apples plus d of ji with apple. So as you can see, there are two kinds of distinct. So you have to basically minimize this and return the answer for every I. Minimize and calculate for every I. Yeah. So this is your this is the basically this can be minimized by minimizing this plus minimizing this. Both of these should minimize. And in order to minimize both of them, you have to apply Dijkstra on two graphs. So first graph you create without apples, like G1 is your first graph, which is without apples. G2 is your second graph, which is with apples. Okay. And now for each node you brute force. For each node I, for each node I in all the nodes like 1 to n, you calculate Dijkstra on G1 starting from I, and that's your distance array D1, which is without apples, and D2 would be Dijkstra again on the graph G2 starting from I, right? Yeah. And then like you also maintain a global order, like let's not call this D1 D2, let's call it no apple, and let's call this apple. So then D1 of I, you'll push back the no apple. So D1 is the 2D vector containing distances, like 2D distances of all the nodes I and j without the apples. Okay, so it's a 2D vector. So D1 of I is sorted. So D1 of I, we for no apple, it's just no apple path that we calculated above. And similarly, D2 of I dot push back the apple path. Similarly, you also maintain D2. Okay. So complexity wise, this is O of like Dijkstra on G1 is, so G1 is given to us, right? So the complexity of Dijkstra is again like E log V plus E log V plus V log E, right? And you got n, which is the number of V, like vertices, so that's V into something like this. So overall this solution, like since it's a sparse graph, sparse graph, meaning that the number of like edges is equivalent, kind of equivalent to number of vertices. So it's kind of like a O of VE solution, which is possible, right? Because this is given. It's, yeah, it is possible. So this is like kind of O of VE log V or something. You can add these terms and just get the complexity, but it'll be quadratic time complexity given this constraint. It's a sparse graph. Yeah, and then what you do is, so now having calculated this, you again brute force. So for each I in 1 to n, so you pick a node I, and then you again brute force on each j, like for each j in 1 to n, and then you pick a node j, and then what we do is your best answer is the minimum of, so you could buy the apples like without the like using the path without buying apples, so that is t of d1 of ij, and then you return back with apples, which is t of d2 of ji plus prices of j, because you also pay prices of j to buy the apples, right? And in the case where I equals to j, this will automatically default to prices of I. This would be 0, this would be 0, and this would become prices of I. So you don't need to like worry about that edge case where what if you buy the apples on I itself. Look, you just travel like this, but you don't have to worry about it. So this is again O of n square, right? So yeah, or v square if you must. Yeah, so overall you solve this problem O of v square. Just going through the code, I'm doing the same thing in the code as well. Yeah, so this I took two graphs. I made the edges. The first graph contains only cost edges without apples. The second graph contains edges with cost and taxes. And then I just do a Dijkstra on all nodes, right? Like we discussed, d1 of I and d2 of I, which looks like this. This is my go is basically my Dijkstra function. It's pretty straightforward. And then I just brute force. That's it. Thank you guys for watching. Bye.